Hello, welcome. Today we are talking about some of the considerations that you might have when making VNA measurements in a cryogenic environment. So one of the things that becomes a concern when you're working in a cryogenic environment is these things have a number of layers of attenuation stages internally, and those things are great for thermal isolation. They're also great for reducing noise. However, that high level of attenuation can be a problem when we try to cow down within the chamber. So what we're doing here today is we have two simultaneous one-port measurements on channel 1 and channel 2. Channel 1 is utilizing our configurable test set here on our PNAX, and channel 2 is coming straight out of port 2 here. Both of them have 40 dB of attenuation in the path, and what we're trying to highlight is the improved directivity you get when taking this configurable test set approach, where you bypass the internal coupler by removing these jumpers and directly accessing the receivers internally and utilizing the external coupler here to do your signal separation. So you improve your directivity, you get a better cow, and then when we measure these identical 50 ohm loads on each path here, we see a significant improvement in our measurement, where in our non-configurable test set scenario, where we have to go through that 40 dB attenuation both on the forward and reverse traveling wave as it gets back to the receiver, we're basically not able to have any real directivity here, and so our measurement is pretty much nonsense, as we have pretty bad cow. But on the other path, we get significant improvement. We see a lot of separation between the two measurements, and that actually starts to look like a 50 ohm load as